Factoring quadratic trinomials when a equals 1. Let's first recall what we're really doing here. We want to, when we're given something in this standard quadratic form, it's a polynomial of degree 2, and in this case we have 3 terms. So our polynomial, more specifically our trinomial, will always be ax squared plus bx plus c. And we use this standard quadratic, this polynomial, to write the factors or things that were multiplied together to give us the original polynomial. And here's what I mean. We'll do this by example. There's 4 examples here. Okay. The first one, if you look off to the left side here, if a times c is positive, okay, if a times c is positive and b is also positive, we're going to fill in this big X on the bottom. This is called our AC method to factor. Okay? In this case, A is 1, and our C value here is 7. So on the top of my big X, 1 times 7 is 7. And the bottom, I'm going to put my B value, B in the bottom, B bottom. In this example, B is 8. Okay? So if we remember, when we want to factor these or find our 2 constants, okay, the 2 numbers that we fill in on the left and on the right need to multiply to the top and add, so multiply to the top and add to the bottom. So if I go to my factors of 7, I only have 2 of them, 1 times 7. 1 times 7 should multiply to 7 on the top, and it does. 1 plus 7 is 8. So I know that's my 2 factors. When a is 1, I can go right to my solution. Okay, I use the 2 numbers that I wrote down on the left and right. X plus 1 is one of my factors, and x plus 7 is my other factor. The next case happens when a times c is positive, but b is negative. Well, a times c is 10, b is negative 11. If AC is positive and B is negative, then the 2 factors are both negative. The factors of 10 that will add to 11 would be 1 and 10, but they both need to be negative. When I add them together, I get negative 11. When I multiply them, I get 10. Since A is 1, I can go right to my solution. X minus 1 is one factor. The other factor is x minus 10. That's my solution. Those are my 2 factors. Third example, if a times c is negative and b is positive. Well, 1 times negative 24 is negative 24, and b is 2. In this case, the factor with the higher absolute value is going to be positive. That means the bigger number is positive. Okay? Well, factors of 24 that are 2 apart, 6 and 4. The bigger number will stay positive. So 4 has to be negative. Let's check. 6 plus a negative 4 is 2. 6 times negative 4 is negative 24. So I have the correct values. I can go to my solution. One factor is x plus 6. This time I have x minus 4 on the left. Sorry, on the right. And my last one, if they are both negative. So if AC is negative and B is negative. Okay, 1 times negative 56 is negative 56, and B is a negative 1. Factors of 56 that are 1 apart are 8 and 7. Okay, the factor with the higher absolute value this time is going to be negative. So the bigger number here will be negative. Negative 8 plus 7 is negative 1. Negative 8 times 7 is negative 56. So my solution, the 2 things that multiply to this original polynomial, would be x minus 8 times x plus 7. And just as a quick review, when I say multiply these together, we can use either our FOIL method, first, outside, inside, last, or the box method. Okay. First, x times x is x squared. The outside two terms, x times 7, is 7x. The inside two, negative 8 times x is negative 8x. And negative 8 times 7 is negative 56. When I simplify, I can combine my like terms there. X squared, positive 7 minus 8 would be negative 1x. And I have minus 56. So from this solution, this is our answer. I checked by multiplying or foiling, and I got the original question. And that's how it always should work out.